Hello and welcome to the video that will provide you with solutions of a quiz on selected applications of derivatives. You're given the task of building 4 offices of the same size using a budget of exactly 500 meters for walls. That means the budget will enable us to buy 500 meters of walls that we can set up the way we want. What dimensions will maximize the total area of each office? Do not consider the ceiling or the roof. Suppose we model the office as follows, like a strip mall. Since the 4 offices must have the same size, let the width and length of each be W and L respectively. Then we must build 8 walls of size W and 5 walls of size L, where L is represented by the vertical lines separating the offices. And then each office will have definitely 2 lengths and 2 widths. So since we have 3 lengths that are shared, the total number of vertical lines is only 5. But since every office has 2 widths, then we have 4 offices that will give us 8 widths. So we will have 8 walls of size W and 5 walls of size L. Based on the given budget, 8 times W plus 5 times L should be equal to 500. If we solve for L, we're going to get L equal to 1 over 5 multiplied by 500 minus 8W. Let the area for each office be A. Then we can represent L to be equal to A divided by W. This implies that A divided by W equals to the value of L, which is 1 over 5 multiplied by 500 minus 8W. Now we have to look at A and we look for the values of W that will give us a maximum area. So consequently, as a function of W, A of W equal to W divided by 5 multiplied by 500 minus 8W. If we can take 1/5 inside these parentheses, we're going to get the equation equal to 100W minus 1.6W squared. And since we're looking for maximas, then we have to equate this equation, the derivative of this, we have to equate it to 0. So first we have to get the derivative of A of W. So A prime of W will give us 100 minus 3.2W. Now we have to equate this to 0 to find out the value of W, and then we'll check whether or not that value is going to lead us to the maximum value. Since 3.2W equal to 100, it implies W equal to 31.25. And since L equal to 1 over 5 multiplied by 500 minus 8W, we can figure out also L to be equal to 50. Now we have these two values. We have to look for the second derivative of A, and that will be A double prime, which will be equal to negative 3.2 at the value of W equal to 31.25. So we can conclude that the concavity at that particular value is going to be downwards. Since the concavity is downwards, it's good news for us because the values of L and W maximize the size of each office, and that's what we wanted. As exercise, we want you to check to see if you can follow a different model. This is the strip mall. Let's take a look at square mall. So what we want you to do is we want you to also check and see if, given the 500 meters of walls, if you can remodel it in the shape of square mall. Then we want to see if we're going to get for the offices, larger area based on the walls of the peripherals. If we can get a better deal, that's just an exercise for you. Let's get to the next question then. Next, determine the concavity of the function f of x equal to x cubed minus 24x squared plus 6x plus 18 and identify any point of inflection. For the function that we have, f prime of x equals to 3x squared minus 48x plus 6. Now we have to take a look at the second derivative. Second derivative is derivative of the first derivative, and that will give us 6x minus 8, and this implies concavity is upwards when f double prime of x equal to 6x minus 48 is greater than 0. This implies that we have this segment from 8 to infinity, not including either. F double prime of x is positive. The concavity is upwards in this segment. Let's take a look at the second segment. For f double prime of x equal to 6x minus 48, it implies concavity is downwards when f double prime of x equal to 6x minus 48 is less than 0, and that will give us this section of the domain, since the interval will be from negative infinity to 8, not including either. Then f double prime is negative, the concavity is downwards. Since the concavity for anything greater than 8 is concavity is upward, and for anything less than 8 concavity is downwards, then 8 must be the inflection point. And to prove that, we just have to evaluate the function's second derivative. We have to evaluate it at 8, and that will give us 0, which is what we want. Next, an aircraft is climbing at 30 degrees angle to the horizontal. How fast is the aircraft gaining altitude if its speed is 750 kilometers per hour? This is gonna make it easy for us to solve the problem. We're gonna look at a right angular triangle, and then we're gonna look at the hypo being 750, and of course the angle is 30 degrees, so the aircraft will start gaining altitude from the horizontal line and going at 30 degrees and climbing up. So we want to know its altitude. The triangle shows the hypo as the trajectory of the plane. The climbing angle is 30. The altitude is perpendicular to the horizontal line, which is this altitude. Now, hence, since sine of 30 is equal to half, implies the altitude 375, which is half of the hypo. The hypo is 750, so the altitude will be half of the hypo, and that's 375 kilometers per hour. So if the plane in 1 hour climbed that much, that means it would have gone a distance of 750 kilometers, and at that point its altitude will be 375. Our next task is to find any extreme values of the function f of x equals to absolute value of 2x minus 5, and then subtract from the absolute value 7 and their locations. That means we want to see if there is any extreme value for this function, and if there is, then where would it be? For f of x equal to absolute value of 2x minus 5 minus 7, we have two cases. The first case is when 2x minus 5 greater than 0. This implies that x greater than 5 divided by 2. Therefore, the first derivative of the function f prime of x is equal to 2. Since the second derivative is equal to 0, there is no extreme value at x greater than 5 divided by 2. Let's take a look at the second case. The second case is we take the negative side. So it will be negative of, between parentheses, 2x minus 5 should be less than 0, implies x greater than 5 divided by 2, and the first derivative will also give us negative 2. Now if we do the second derivative, we get 0. So there is no extrema for x greater than 5 in both cases. So for x equal to 5 divided by 2, the value of the function will always be negative 7 for both cases, case 1 and case 2. Therefore, the function has local and absolute minimum equals to negative 7 at the point x equal to 5 divided by 2. The function has no local maxima, since for both cases the function has no extrema. That's it, and thank you for watching. You have a great day, and subscribe for the channel because you're going to get some interesting questions and quizzes and also shortcuts in solving problems. Good luck. Goodbye.